Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem Chefs Like Good Sequences, which is an easy level problem and also an October lunchtime problem. So let us see the agenda for today. First, we will try to understand the problem statement. Then we will understand the concept. Then we'll discuss the pseudocode, or you can say a proper summary of the entire problem. And then we will do a quick walkthrough of the code. So let's get started. Hey guys, did you know that CodeChef also conducts free live classes on Unacademy where we cover each possible topic related to competitive programming? We have beginner courses like Introduction to Java and C++, Recursion, Basic Data Structures, and we also have advanced courses just like Dynamic Programming, Graph Theory, Trees, Segment Trees, and there are many more courses to come up which will help you in enhancing your competitive programming. These courses are covered by the top coding experts from around the world who are IOI medalists, ICPC World finalists, and have worked in companies like Google, Amazon, LinkedIn, Flipkart, and all these companies that you always dream of. All you need to do is download the Unacademy app, or you can also register yourself on unacademy.com by clicking here on Start Learning and choosing your goal as competitive programming. You can also take the paid plus subscription in order to get additional features and individual level support. Also, we have 6-star and 7-star rated teaching assistants to clear all your doubts during and after the live sessions. To get your paid plus subscription, you can use my referral code, which is Prachi16, and get an instant 10% discount. So hurry up guys, subscribe to Unacademy Plus and kickstart your journey of competitive programming. In the problem statement, we are given a sequence A1, A2 up to AN. So you can see an example here. Let us take this example of the sequence as A, and the length of the sequence is n equals to 9. So A1, A2 up to A9. Now, it is also given in the problem statement that Chef likes to change the sequence every now and then, and for that we are given few number of queries. Each query is of the form x, y. Now what is x and what is y? So x is the index of the element that will be changed in the sequence, and y is the new element that will come at index x. So which means that after every query, a of x will become equals to y. So if your x is suppose 4 and y is suppose 3, then at index 4 we will remove this element 9, and instead of this element 9, y will come here. So y is 3. So it means that at index 4, 3 will be present now. So this is what is given. And one more thing is given, that note that the queries are not independent, which means that after each query, what will happen, that this change that we are making, that is a of x equals to y, this will retain in the sequence. That is, after each query, this change will be maintained in the sequence, and according to this sequence only our calculation will be done, whatever the problem statement is asking us to do. So it is not like that each query, for each query we will use the initial sequence. No. Now what are we actually supposed to find after each query? So for each query we have to find the length of the longest good subsequence of the current sequence. Now what is a good subsequence? So it is given in the starting that a good sequence is one which does not contain any two adjacent identical elements. So if you can see here that 2 and 2 is identical to 2. So, and they are also present adjacent to each other. So, these two elements cannot be present in a good sequence. A good sequence will contain elements such as 6 to 9. So this can be called as a good sequence or good subsequence because it does not have any adjacent identical elements. Now, before we understand that how we can find the length of longest good subsequence, first we will understand what a subsequence means. So, a subsequence is an ordered subset of the sequence, of the given sequence. What does it mean by ordered subset? So, subset, you know that you can take any of the elements into your set from the original sequence, but ordered means that you cannot change the elements, the order of the elements that are present in your original sequence. Like 2 in this sequence comes after 1, so in your subset also 2 will come after 1. You cannot make your or subset as 2, 1, 3 and then call this a subsequence. No, it has to be ordered. So as you can see that I have already listed all the possible subsequences of this given sequence. Now, out of all the possible subsequences, we are supposed to find the good subsequence, right? It was given that we have to find the good subsequence. And what was the definition of good subsequence? That it should not contain any two identical adjacent elements. So let us rule out those subsequences which have identical elements adjacent to each other. So like we will rule out this one because 2 is present adjacent to each other. Then we will have to rule out this one, again this one, and these two will again be ruled out. So now we are only left with some of the subsequences, and all of these can be said to be a good subsequence. But we were supposed to find the length of longest subsequence, longest good subsequence. So you can clearly see that the length of longest good subsequence here is this one, 1, 2, 3. That is, the length is 3. So now coming back to our original sequence, now we will find the length of longest good subsequence in our original, the initial example that we took with the problem. So in this example, there will be many good subsequences like we discussed earlier, that there can be many subsequences which can be good according to the problem. But we are only supposed to take the longest one. So the longest in this example will be 62924. Why? Because our good subsequence should not contain any two adjacent identical elements. So it has picked a single element from a group of similar elements. As you can see that this is one group of similar elements, this is the second group, then this is the third group, this is the fourth group, and this is the fifth group. And from each group of similar elements, we have picked up one element each. So this is how our longest good subsequence is formed. But how can we find out the length? So length can be easily found out if we just check the adjacent elements to be non-identical. That means that we check that we count the number of non-identical adjacent elements. So if we do that, then we will be able to count these groups. How? Because between each of the two groups, there will be a change in the element. That is like if when there is a transition from group 1 to group 2, then the adjacent elements have to be different, right? 6 and 2 is not identical. It can never be identical because they are a part of two different groups. So what we can just do is that we can just check the ith element with the I minus 1th element. And if the ith element is not equals to I minus 1th element, then that means that they are non-identical, and we will increment our count by 1. So similarly, we will get one count here, then we'll be getting one count here because there is a change in the group from 2 to 3. Then again we will get one count here, then one count here, and that's it. So 4 counts we will get by checking the adjacent elements for non-identical, that is if they are not non-identical or not. And we are only getting 4 as our count. Why? Because for the first element we do not have any element before it. So if your I is equals to 1, then you cannot check this with the I minus 1th element because that is not present. So that is why your count should always initially begin from 1, because the first element will always necessarily be included in counting the length of longest good subsequence. So count we have taken 1 because of the first element, because that will always be included. And then what we will just do is that we will have to count the number of adjacent non-identical elements. So here we have counted them to be 4, and since our count was initially 1, so it will keep on incrementing 4 times. So 4 times it will be 2, 3, 4 and 5. So count will become equals to 5. And as you can see here, the length of longest good subsequence is 5, as you already know after seeing this sequence. So we have found out the method how we can calculate the length of longest good subsequence. But this was for the initial sequence that we calculated this length. But we are not supposed to do this in the question. We will be given queries in the question of the form x, y, and after making this change in the sequence, that is a of x equals to y for each query, then we will have to find the length of longest good subsequence in this in the changed sequence. So as you can see that we were calculating the adjacent non-identical elements. So for that, time complexity came out to be order of n, because we will have to run a loop in order to check the adjacent elements. And there will be q queries. You know that there will be q queries. So for each query, we will have to, if we try to find the length of longest good subsequence by this method, then for each query, we will take order of n time complexity. So a total time complexity of n into q will be required if we follow this method. So let us check the constraints that is it a feasible method? So let us go straight to the constraints and check that n and q is given of the order of 10 to the power 5. That means if your time complexity is n into q, then a total of 10 to the power 5 into 10 to the power 5 will result in order of 10 to the power 10, which is very large and will not get accepted, and you will definitely get a TLE in this answer. So we have to think of a cleverer approach to handle this problem. So what can be that approach? You should think about it once and then go to the solution, go to the main solution. A better approach to calculate the length of the longest subsequence after each query when the element at index x has been changed to element y, we will have to calculate the length of the longest subsequence of the original sequence. This is our original sequence and we had already calculated this length that was equals to 5. That is the length of longest subsequence for the original sequence. Now, suppose we are given a query x, y equals to 4, 3. Okay. So, at index 4, this change is going to be made. So, at index 4, instead of 9, now 3 will come. So, this is your xth element of the sequence. Now, you already know that whatever contributions to this length was made due to the adjacent elements only, by checking that if your adjacent element is non-identical or not. So, you know that the change in this length will only be made because of the new element by checking on its adjacent elements only. So if your x element is changing, then the contributions will only change because of x minus 1th element and x plus 1th element. and no other element can affect your length of the longest good subsequence, because rest all the elements are same, but only this x the element is changing. So we will have to check compare x minus 1 and xth element, and we will have to compare x plus 1th element with the xth element to check that if they are non-identical or not, that is with the new element. And also we will have to do that with the previous element, because the previous element, or you can say the present element, had already contributed to this length. So first we will find out what contribution the present element had made to this length. So if your for the present element a of x, when this change has not been made, then first we will check that if a of x is not equal to a of x minus 1. So in this case it will make a contribution of 1 to the length, and otherwise if element at x minus 1 is equals to element at x, then it will make a contribution of 0. And similarly for element at x plus 1, that will also be compared with the element at x. Same thing, if it is not equal, then the contribution is 1, otherwise the contribution is 0. So from both these contributions you can see that contribution to the length of the longest good subsequence can either be 0, it can either be 1, or it can either be 2, right? 0, that means x minus 1, x and x plus 1 all are identical. 1, if any of the two, like x minus 1 or x and x, or x or and x plus 1, any of the two are non-identical, or if both are non-identical. Now second time what we will do, that after we change a of x to y, that means when we have changed this value according to our query, after that also we will have to check what contribution this new element is going to make to this length of longest good subsequence. So for that again, now I have written y here to make you understand that we are checking for this new element now, that what contribution it is making to the length. So for this also we will check just exactly similar to what we checked here, that if y is not equals to a of x minus 1 and if y is not equals to a of x plus 1. So if they are not equal, then the contribution will be 1 each, otherwise the contribution will be 0. So again the contribution can either be 0, 1 or 2. Now let us call this contribution to length, that is because of the present element, we will call this PC. Let's call it PC. And the contribution to length because of the new element, that is y, let us call this NC. Alright. So what will be your answer? So your answer will be length equals to length minus PC plus NC. That means what you will do, that from length, that is of the present subsequence, like this is your original subsequence, and you know for the original subsequence your length of longest subsequence is 5. So here length, then minus PC. Why? Because for the present element, that is at a of x, that is present at xth index, so that had already contributed to the length. It had already contributed something to the length, that is either 0, either 1 or either 2, any of these three values. So that you will have to subtract from the length, because now a new element will be present in its place and it will contribute different values to the length, and you do not know that. So you will have to subtract this. Then you will calculate the contributions made by the new value at the same index, that is xth index, that is with element y. And again the contribution can be either 0, either 1 or 2. So you are supposed to add this contribution to your length, and this will give you the length of longest good subsequence for the current sequence. And after doing this, you are also supposed to change this, like here we took x comma y equals to 4 comma 3. So at index 4, we will change this to 3. We will change 9 to 3. So let us just check for this query what will be our answer. Our length was 5, then minus PC. So this PC value, if a of x is not equals to a of x minus 1, so 9 is not equals to 2. So 1 will be contributed. Again 2 is not equals to 9, so 1 will be contributed. So minus 2, and then we will bring a new element here. New element is 3. Now 3 is not equals to 2. Again 3 is not equals to 2 on both its sides. So again the contribution will be 2. So here the length of longest subsequence will remain 5. But if you take some other query, like suppose if you try to change this this element, if you change this element to let's say suppose 1. If you change this element to 1, then the length of your longest subsequence will change. And note that for the next query, this 3 that has already been changed will be maintained in your current sequence. So that is all, guys. This is the question. Now talking about the time complexity, how our time complexity will reduce by using this approach. So earlier your time complexity was coming out to be order of n into q. If you used the traditional approach to find out the length of longest good subsequence. But using this approach, your time complexity will only be order of n plus q. How? Because for each query, you are just calculating this value, length minus PC plus NC, and both of these calculating the contributions to the length from the present value and from the new value. This will only take order of 1 time complexity, and for each query it is taking order of 1 time complexity, and there are q queries. So that is why for q queries it will take order of q time complexity, and once and why n, because for the original sequence we will have to find the length of longest subsequence by using the traditional method, which takes order of n time complexity. So that is why the time complexity for this question for our approach will be n plus q. Now let us discuss a quick summary of whatever we have discussed here. So now let us discuss a quick summary of the code. So first you are supposed to find out the length of longest good subsequence of the initial sequence, and this you will do by calculating the number of non-identical adjacent numbers. Now for each query x comma y, what we discussed is that whatever contribution a of x will make to the length of longest good subsequence, we will have to subtract it from length. That is, this portion is showing you that you are subtracting PC from the length. And once you do that, then you will change the value at index x to y, because this is the new element. Then we will have to do the same for the new element, but instead of subtracting, we will have to add the contribution to the length. So this value, these two lines that you see here is that we are adding NC to the length. Now what is this NC? It is the contribution that the new value y is making to the length of longest good subsequence. So we are adding it if a of x is, or you can say y is not equals to a of x minus 1, or y is not equals to a of x plus 1. Then each time we will add 1 to the length, because what we were initially doing is that we were calculating the adjacent non-identical numbers, the number of adjacent non-identical numbers. So we are maintaining that flow here only. And at last, this is just a point to note that this change a of x equals to y will be maintained after each query. So this has been explained several times. Now, before going to the code, I must say that you should try the code on your own, because this is a very simple problem. You will have to take care of some boundary conditions, but that you must think on your own and try the code yourself. But still, if you get stuck somewhere, then you can refer the code, which I'll be coding in Python. Alright guys, so now we will discuss the code which is in Python. On your right you can see the variable description if you want to refer it at any point of time. So first few lines are the input as always. First line is the input for number of test cases. Then we have input for the number of queries and also the length of the sequence, that is n. Then we have the sequence itself. And now I have taken length equals to 1. So remember that we had to find out the length of longest subsequence in our original sequence, and the count initially had to be 1 because we will always have to include the first element in our longest subsequence. So that is why here length is equals to 1 initially. And this loop that you can see here, it is calculating the number of adjacent non-identical elements which will give us the length of the longest subsequence. And here you can see that I have directly done length plus equals to a of I not equals to a of I minus 1. So what will happen is that if a of I is not equals to a of I minus 1, then the condition will be true and it will return 1 as the answer, and 1 will be contributed to the length, or you can say added to the length. And if this condition is false, then it will return 0 as the answer, and the 0 will also get added in the length, but it will make no difference. Now we are running a loop again for the number of queries because we have to see for each query that what is the length of the longest subsequence. So for each query we will input x and y, and then here I have done one thing, that is x equals to x minus 1. This is because in the problem the sequence started from 1, but in our arrays or in our programming, whatever data structures we use, the indexing always starts from 0. So like suppose if your x is equals to 1, then that means that it is referring to the element present at index 0. So that is why you will have to do x equals to x minus 1. Now this is just the same thing that we just discussed in the summary. If your x is not equals to 0, so this we are checking for the boundary test cases, right? Because if x is equals to 0, then you cannot check for x a of x minus 1, because 0 minus 1 will be minus 1, which is a negative index. So you cannot check for that condition. So that is why you will have to make a check here that if x is not equals to 0, then first what you will do is that you will subtract whatever contribution was already made to the length by your present element, that is a of x. Then you will add to the length the contribution that will be made by the new element, that is y. So length minus equals to a of x not equals to a of x minus 1. This we are doing for the present element, whatever contribution it has made, that has to be removed, and then we will have to add the new contribution. So that is because of the element y. So we are checking y not equals to a of x minus 1. Now this second condition is for the boundary condition when we are checking for a of x and a of x plus 1. So if your x is the last element of the sequence, last element of the sequence will be n minus 1. If your x is equals to n minus 1, then you cannot check for an element present at a of n, because there will be no element and you will get an error if you do that in programming. So that is why we will have to check that if your x is not equals to n minus 1, only in that case you will check these two conditions, otherwise there is no need. So again we are doing the same thing, that first we will remove the contribution that was made by the present element to length, that is length minus equals to a of x not equals to a of x plus 1, and then we will add whatever contribution the new element is making to the length. So we will check y not equals to a of x plus 1 and add it to the length, whatever this answer will be. So after we have done that, now we will also change the element at index x to finally y. because it was already given in the question that this change will be maintained for after each query. And then finally we will print the length of the longest good subsequence which we were supposed to print after each query. So that's it guys, this is our code. Now like the video if you understood the concept. Please post any suggestions or feedback that you have. And also if you have any doubts regarding the problem, or suppose you have new solutions or better solutions to the problem, then you can always post them in the comment section so that everybody can benefit out of it, and we'll definitely try to solve all your doubts. Also please make it a practice to solve this problem, code this problem, and then submit it even after the contest is over, because this will help you in enhancing your coding ability. And also do not forget to subscribe to our channel and hit the bell icon so that you can always be notified of the upcoming updates.